Okay, welcome to Knowledge Share channel, and in this video, again we will be discussing about one more power electronic device or equipment which is called as cycloconverter. The cycloconverter is a very important equipment which is used nowadays in most of the industries with high power ratings. Okay, anyway, we will go to the applications later on. Okay, so first let us go into the discussion of why we need such an equipment actually, because what are the drawbacks of the other equipments which this particular cycloconverter is going to overcome. So that's what we are going to discuss, and then we will discuss about what is a cycloconverter and what are its types and how it works, and we can see some waveforms of different modes and other things. Okay, and then we will close it. So this is how this entire video will look like. So anyway, before going into the topic, I just want to convey what is the need for the cycloconverter. Okay, so what is the problem is, earlier they found only the AC voltage controller. You know what is AC voltage controller, because it will be using a triac in series with source. That is, a triac will be connected in between the source and load. So triac will be controlling the output voltage. Is it right? So there are many applications where we need to control the output frequency, because this triac based AC voltage controller can produce only variable output voltage, but the output frequency is constant. Okay, and there is also another one method. For example, again, if I use, for example, if I have two-stage conversion is there. In case of two-stage conversion, we will be using, initially we will be using some chopper or something like that, and again we will be using inverter. Okay, and again so that we can achieve the variable frequency. Okay, so like this. So again we want to convert, this converter also has to be used. So what happens is, we want to convert AC to DC, DC to AC again, in order to achieve this particular variable voltage and variable frequency conversions in case of power electronics things. So this what happens is, this increased the cost. Not only cost, this also increased the size of the equipment, as well as you need more controllers in order to get the output voltage. Many intermediate conversions are needed. So what to say, losses are also very high. It is efficiently very less. If you go for two-stage conversion is possible. Okay, so you want to convert the AC to DC and again DC to AC. So by that what we can do is, in between you can use a chopper. Okay, so by using chopper we can control the voltage, whereas by using the AC voltage controller you can control the, what to say, by using the inverter you can control the frequency. So it is a two-stage conversion. As I've said, it is very costly, high losses, as well what to say, efficiency is very less. Volume is very high because more number of converters and inverters are used. So in order to avoid all those things, if what happens, what if we have one single equipment which can convert fixed AC voltage and frequency to variable AC voltage and frequency. So that's what this cycloconverter does. So, and also we don't use any intermediate converters. Okay, we don't use any intermediate converters, and intermediate conversion stages are now avoided, and because of which the cost is very less, as well the power loss is very less, the efficiency is very high, volume is also very less. So this is the advantage of the cycloconverter. Hope you are clear with why we are going with the cycloconverter. So it is nothing but a voltage and frequency changer. Okay, it is nothing but a voltage and frequency changer. That is, you can control the output voltage. Okay, as well you can control the output frequency. So both can be controlled, and I am not going to use any conversion or DC to AC or AC to DC conversions in between that particular equipment. So that is called a cycloconverter. Okay, so hope you are all clear with what is cycloconverter. So again you can see that there are two types of cycloconverter. Basically it is classified into two types. One is called as a step down. One is called as a step down cycloconverter. The other one is called as step up cycloconverter. So as we have discussed in transformer, that is two types is there, yeah, step down and step up. So what is a step down actually? For example, in case of a transformer, if the output voltage is less than the input voltage, it is called a step down transformer. If the output voltage is higher than the input voltage, it is called as a step up transformer. So similarly here also you are having two different types of cycloconverters. One is called as step down cycloconverter. So in this we have to consider the frequency. So for example, if the output frequency is less than the input frequency, then it is called a step down cycloconverter. If the output frequency is greater than the input frequency, then it is called a step up cycloconverter. Okay. So only thing you want to understand is, in case of step down cycloconverter, natural commutation is used. What is natural commutation? That is, for example, the current will pass to 0 and the SCR will be switched off, and because of which the losses will be very, very less. Whereas in case of step up transformer, we will be using forced commutation techniques. Forced commutation means we have to use some external voltage commutation or current commutation. So that's a different story. Okay. So we are in this again, we will be discussing only about the step down cycloconverter only. So what is step down cycloconverter? It is nothing but the output frequency will be less than the supply frequency or input frequency. Okay, and natural commutation will be used in order to switch off the transistors. That is called as step down cycloconverter. Okay. So what to say? Before going into the topic, if you are really very clear with what are the applications. So applications are very, very important. For example, this particular cycloconverter is widely used in low speed AC drives. Okay, what is the low speed AC drives? For example, if an AC drive is working only between 0 to 20 hertz, then no need to go for inverter. You have to go for cycloconverter, which will reduce the cost very much. Okay, if you go for inverter, the cost will be very high if you operate in a low frequency zone. So you can see that cycloconverter are highly preferred for low frequency AC drives, okay, in order to control the speed, and also the power should be very, very high. For example, above 15 megawatts, okay, 15 megawatt low speed AC drive. Okay, this particular cycloconverter is the best option for any such applications. Okay, and also for induction heating it is used, because normally in case of heating we will be using low frequency, and so this induction heating also this particular cycloconverter is used. As well, it is used in cement mills, ball mills, and also it is used in SVC, that is static work compensator. What is a static work compensator? So I don't know whether you are aware of that. SVC, in short it is called as SVC. You can just surf the net. Okay, SVC, static work compensator, is used in the transmission line in order to inject the reactive power so that the power factor can be improved in the transmission lines. So that is the purpose of this SVC. Also for SVC, this particular cycloconverter is used. Okay, as well in aircraft it is used. Aircrafts, in ships it is most widely used. Okay, in ships, in aircrafts, this cycloconverter is most widely used. Okay, because wherever we go with low frequency things, we will be going with the cycloconverter. Okay, so we have seen the types and we have seen the applications, and there are some problems also. There are some problems, because the cycloconverter, the output waveform is quite not good. It is not a pure sine wave. It is, the output voltage waveform is highly distorted. That is the main problem. So you have to use costly filters in order to get a pure sine waveform. So this is one of the major drawbacks in case of the cycloconverter, and also it results in low power factor also. Okay, the power factor will be quite less. Okay, so these are all some of the problems. So we have to use again some additional power factor in order to power factor improvement device if you use a cycloconverter. Okay, so these are all some of the problems associated. One is the output voltage waveform is not good. It is highly distorted. Okay, so we have to use high filters. Okay, high power rated filters in order to eliminate the harmonics and other things. And second one is the power factor will be quite less in case of the cycloconverter. If you use a cycloconverter, because there is a quite lagging effect of the current with respect to voltage. So based on the circuit arrangements, okay, so based on the circuit arrangements, you can see that there are two types. Okay, so see, there are two types of circuit configurations. See, like for example, that is the circuit arrangements itself can be changed. Okay, so the same output waveform can be achieved by two different circuit configurations. Okay, so that's called as if you use one configuration, that is called as center tapped cycloconverter. The other configuration is called as a bridge cycloconverter, bridge type cycloconverter. The center tapped cycloconverter is having many drawbacks, like you have to use a center tapped transformer. So it will be using the center tapped transformer in order to achieve the different variable voltage and variable frequency output. So that is not advisable, and it is, but this is the oldest type center tapped transformer. But now everybody has switched to bridge type cycloconverter. So bridge type cycloconverter, the losses are also less, the volume is also less. So because of this, the bridge type cycloconverter plays a very vital role in nowadays in all the industries compared to the center tapped transformer. So in this video also I will be discussing only about the bridge type cycloconverter, as well the step down type of cycloconverter, not the step up. Okay. Moving on, okay, so this is actually a step down bridge type cycloconverter. This is actually the what to say, that is step down cycloconverter bridge type, right? So how it works? So it consists of two fully controlled bridge, is it right? So you can see that this is one bridge, P1, P2, P3 and P4. This is one bridge, and this bridge is called as a positive bridge. That's why it is named as P1, P2, P3, P4. So you can see that the alternate SCR should be in sequence, P1, P2, and this is P3 and P4. Similarly, this particular things, you can see that this particular bridge is named as N1, N2, N3 and N4, and similarly the opposite diagonal are N1 and N2. Again, similarly this opposite diagonals are called as N3 and N4. This sequence is very, very important. If you just change the sequence, the output may get short circuited. So the sequence of triggering the SCRs, the name convention is very, very important in order to get the correct output wave shape, okay? Otherwise it will result in a short circuit, okay? So here you can see that this is called as a positive bridge and this is called as a negative bridge. So two bridges are there. I can see the load is connected between the two bridges. So this is the output voltage. Normally the load will be on the right end, but here you can see that the load is connected at the center. Okay, it is not in the right end, it is at the center. So two bridges are given with the AC supply. So the same AC supply is also here. Okay, so AC supply here with B and C is given. Here also the B and C is there. Okay, so both. So let us discuss how it operates. Okay, so it consists of two full converter bridges. Full converter, it is not a half converter, it is a full converter bridges, and you can see that both are connected in opposite direction. You can see that P1, P2, P3, P4 are connected in the upward direction, whereas N1, N2, N3, N4 are connected in the downward direction. Okay, so this is what you want to observe. Okay, so both are connected in opposite direction. Both the bridges are connected in opposite direction. As I have already told, if you trigger bridge 1, you will be getting the positive cycles. Okay, P1, P2, P3, P4, if you trigger, you will be getting the positive cycle. If you trigger the N1, N2, N3 and N4, you will be getting the negative cycle. Okay, I will tell you how. Okay, and you can see that one very important thing you want to maintain is, okay, two bridges should not conduct together at the same time. For example, the two bridges are conducting at the same time. For example, if P1, P2, P3, some switches are on, this N1, N2, N3, N4 should be off. Okay, and if suppose if N1, N2, N3, N4 are on, this P1, P2, P3 and P4 should be 100% off. If you mistakenly, instantly, if you trigger both the bridges, then it will result in a short circuit. So this particular triggering is independent from this particular triggering. Okay, for example, if P1, P2, P3 and P4 are on, this particular bridge will be completely off, or I will not be viewing any triggering pulses. If this particular thing is, for example, if N1, N2, N3 and N4 are on, then this positive bridge, that is P1, P2, P3 and P4 will be off. So both the bridges should not be switched on simultaneously, otherwise it will result in a short circuit. It is the main important thing you want to observe. So during positive half cycle, what is this positive half cycle? You can see that from 0 to pi, P1 and P2 will be forward biased, is it right? So P1 and P2 will be forward biased, and you can see that it will be triggered at alpha. Okay, so you can see that both P1 and P2. So for example, AC, the positive and negative will be changed. So here will be positive and here will be negative. So positive is given. So P1 and P2 will be forward biased, and P3, P4 will be reverse biased. So if we give the trigger pulse to P1 and P2, it will start conducting, and the output voltage here you will be getting the positive and negative will be there. What happens during the negative half cycle? Negative half cycle, this will be negative and this will be positive, and you can see that P1 and P2 will be reverse biased, whereas P3 and P4 will be forward biased, and again you will be giving the supply will be like something like C, P3, A, O, okay, P4 and like this, okay, P4B. So this is how it works. Okay, so similarly, so for example, if I want two half cycles, okay, two positive cycles, I have to switch on P1, P2 and P3 and P4 simultaneously. If I want two negative cycles, and similarly here you can see that during the next positive half cycle, N1 and N2 also will be forward biased. But you can see that when you switch on the N1 and N2, what is going to happen is, okay, when you switch on this N1 and N2, this phase, you can see that the output voltage is getting reversed. So when you switch on N1 and N2, the output voltage is getting reversed, because here you will be getting positive and negative will be on A. Okay. So from this we can understand that if I want a positive cycle, I will be operating only this P1, P2, P3 and P4. If I want negative cycle, I will be operating N1, N2, N3 and N4. So for if the input cycle is positive, I will be operating P1 and P2. If the input cycle is negative and if I need the output cycle positive, then I will be operating P3 and P4. If the input cycle is negative, or if the input cycle is positive and if I need the output negative, I will be operating N1 and N2. If the input cycle is negative and if I need a negative cycle, then I will be operating N3 and N4. So like that, by switching on the different sequences, you will be getting the different output voltages of positive and negative things. Is it right? So this is how it operates. Okay. So by operating bridge 1, you will be getting the positive cycle. By operating bridge 2, you can get negative cycle, and it goes on. Okay, and the cycle will be goes on. So for example, if I want to get for example f naught by 2. So this is how. Okay, so I will be switching on P1 and P2 and then P3 and P4. So this negative will be converted to positive, and similarly N1 and N2 during this case, and N3 and N4 during this case. So like that, you can see that you'll be having 2 half cycles in the positive and 2 half cycles in negative, and similarly 2 half cycles in the positive and 2 half cycles in the negative. It goes on. So you can see that the fundamental waveform, you can see that, so it will be something like this. So here the frequency has been reduced. Is that right? So if you put a filter, you will be getting a fundamental waveform which will be something like this, and so the output frequency is getting reduced. So this is called as step down cycloconverter, because your frequency, because your time period is getting increased. So here you can see the time period is from 0 to 2 pi, whereas here you can see that the time period is from 0 to up to 4 pi. So here for one cycle you are having 4 cycles, whereas here for one cycle you are having only positive cycle and negative cycle. Here for one cycle you will be having 2 positive cycle and 2 negative cycle. So if I want 3 positive cycle and 3 negative cycle, yes, that is also possible. If I want 4 positive cycle and 4 negative cycle, yes, that is also possible. So by switching on P1 and P2, P3 and P4 continuously for 4 different cycles, I can get. And similarly, if I switch on N1 and N2, N3, N4 for 4 different cycles, I can get. Okay. So by controlling the bridge, okay, you can see that you can get different. So this is nothing but this output frequency by 2. So similarly, if I want to get a supply frequency by 3, so you can see that you are getting 3 cycles in particular, one. Okay, one positive cycle you will be getting 3 cycles, the other positive cycle will be getting the 3 negative cycles. So P1, P2, P3, P4, P1, P2. Then you go for N3, N4, N1, N2, N3, N4, like that. So by changing the switching sequence, you can get the Fs by 3. Suppose if I want Fs by 4, again I can do that. P1, P2, P3, P4, P1, P2, and again P3, P4. Okay, so here P3, P4, and similarly N1, N2, N3, N4, N1, N3, N4. So like that, I will be getting the negative cycle. So you can see that from this is nothing but Fs by 4, because for one full cycle, you can see that this is the mean sine wave. So this is the mean sine wave. So you can see that it is taking 4 pi. Until 4 pi. So that's why the frequency is getting reduced. So time period is getting increased, so frequency should reduce. So time period and frequency are inversely proportional. So you can see that by controlling the bridges, sequence, timings, you can get the output frequency changed. As well, I can control the output voltage by controlling the firing angle alpha. If I give high firing angle alpha, then I will be getting the less output voltage. If I give the less firing angle alpha, then I will be getting the more output voltage. Okay. So this is how it operates. Hope this video helps you. So thank you, and if you really like this video, please give a thumbs up, and as well if you have any questions, give a small comment. As well, if you just find this video will be useful to someone, you can just share it. As well, if you find that this particular the videos which I post in this particular channel will be useful to you, you can subscribe, which can just give a small notification in putting more such videos. So thank you, and see you in the next video.